Hello students, myself Kainat from Alamgul, and this is the lecture 6 about acceleration. This will be about acceleration. We'll be learning about this. And in the last class that we studied about we did some of the examples on rate of motion. So today we will know about something acceleration. Okay, so acceleration is nothing but defined as the rate of change of velocity with respect to time. Fine. So means what is that? Just like velocity. Velocity is what? Velocity is rate of change of distance, right? Velocity means the rate of change of distance upon time. Okay, rate of change of distance upon time means distance traveled by a body upon time. And likewise, acceleration is change in velocity upon time. Fine. Change in velocity. Acceleration is nothing but denoted by a, small a. It is change in velocity upon time. Okay, delta t. Fine. Change in velocity is denoted by delta v, and change in time is denoted by delta t. Fine. So this will be a delta v upon delta t. Delta v means what? Something velocity must be in the final velocity and initial velocity. So it's let's take as the final velocity as v and initial velocity as u upon t, whatever the time be taken. Okay, so this is a is equal to v minus u upon t. This is the formula for acceleration. Okay, change in velocity upon time. Fine. So this is the formula for acceleration. Here you can see the formula v minus u upon t. Okay, final velocity we take final velocity as v and initial velocity as u. And time, as you all know, that time is denoted by t. Fine. So this is called acceleration, and its unit is meter per second square. As you can see that the unit of velocity is meter per second. Both are the velocity, so unit will be meter per second. You will not do like this, meter per second minus meter per second will be zero. No, this is only denoting the unit. Okay, so meter per second in the numerator and second in the denominator. So if we simplify it, then what we'll get meter per second square. Okay, so we can write it as like this, meter second over minus 2. Fine. Means ru- uh, sorry, power minus 2. Fine. Raised to minus 2 a meter per second square. Okay, so this the unit of acceleration, SI unit of acceleration is meter per second square. It is a vector quantity because velocity is a vector quantity. We all are knowing velocity is a vector quantity. That is why the acceleration is also the vector quantity. Okay, if it is in acceleration is taken as positive if it is in the direction of velocity. If the acceleration is in the direction of velocity, means in the body is going in this direction only, and the body has got accelerated in this direction only, means its velocity is increasing, then acceleration would be positive. But if it would be negative in direction, means just like something as someone has applied a brake in to his bike, so what will happen? The acceleration would be in the negative direction, means opposite direction to the rate to the direction of velocity. Then it will be taken as negative acceleration. Okay. Okay, and if the body is not changing its velocity, then it will be a constant velocity with zero acceleration. Okay, with zero acceleration, because if velocity, if the body will not change its velocity, तो क्या होगा? V minus u upon t. The formula is v minus u upon t, right? So v is the same as that of u, means u hasn't got changed. V is same as that of u. U minus u by t. U minus u will be zero. Zero by t, right? Will be zero. So acceleration would be zero if there will be no change in velocity. Okay, and when the acceleration is positive, then we say acceleration, and when it is in negative direction, then we say deceleration or retardation, or you can also say negative acceleration. Okay, fine. So acceleration can be classified as two types: uniform and non-uniform. Uniform, why? Because everywhere we have seen that uniform motion, non-uniform motion. So that is why acceleration would be also of two types, that is uniform and non-uniform. If the rate of change of velocity is constant, then we'll say कि uniform velocity, then we'll say कि क्या हो रहा है कि uniform velocity हो रही है. But if the body is changing its velocity with respect to time in um, means not equally, so then we will say that the acceleration is non-uniform. Just suppose that in 5 second a body has moved, a body has changed its velocity from 0 to 5 meter per second, okay, and then in another 5 second the time interval is the same. Another 5 second the body has changed its velocity to 12 meter per second. Now here see, the 5 meter per second velocity it was, and here now 7 meter per second. So this is not equal, right? This is not equal. So change in velocity is not equal here. That is why we'll say ki this is non-uniform motion. But if the body is changing, if it would be 10 meter per second, then means the rate of change of velocity is same, so that is why it will be constant. Sorry, no, a uniform velocity. Every time the rate of the velocity is getting increased by 5 meter per second every 5 seconds, okay. That is why we'll say ki yes, this velocity, this acceleration is what, uniform acceleration, okay. Now let's see an example. Let's see an example starting from the stationary position. If the if in the question it's given he is, the body has started from the stationary position, then what we'll take without any second thought, we'll take u as 0, means initial velocity as 0. The body is in rest position, okay. Now the car attains a velocity of 5 meter per second in 20 seconds, okay. Now velocity means final velocity is given as 5 meter per second in 20 seconds. T is given as 20 seconds. Then the driver of the car applies a brake. It means it is negative acceleration, okay. It is about negative acceleration, such that the velocity of the car comes down to 3 meter per second in the next 6 seconds. Okay, fine. Now let us take it as u1 and v1. Fine, u1 and v1. Now this v1 has become, now see, this v1 has become u2. Why? Because now it has applied a brake. पहले तो क्या हो रहा था, एक्सेलरेट हुई बॉडी 0 to 5 मीटर पर सेकेंड गई, लेकिन अब क्या हुआ कि आफ्टर 20 सेकेंड क्या हुआ कि ब्रेक अप्लाई किया गया। ब्रेक अप्लाई किया गया मतलब पहले 5 मीटर पर सेकेंड थी, लेकिन क्या हुआ, ब्रेक अप्लाई करके उस कार को कहां पे ये जो U2 हो गया हमारा 5 मीटर पर सेकेंड हो गया, और जो हमारा V2 हो गया वो क्या हो गया 3 मीटर पर सेकेंड, 3 मीटर सॉरी 3 मीटर पर सेकेंड, ओके। बिकॉज अब वेलोसिटी जो हो गई वो डिक्रीज हो गई टू 3 मीटर पर सेकेंड इन नेक्स्ट 3 सेकेंड। सो इट विल बी T1, then it would be T2, 6 seconds. Calculate the acceleration of the car in both the cases. So we have to take both the cases. So for A2, we are having all of the data, U, A, U, V and T, U, V and T. Everywhere we are having every data. So all the data. So A1, for A1, it will be V1 minus U1 by T. Okay. So V1 will be 5 minus 0 by 20. So how what it will be? It will be 5 by 20. It means 1 by 4. It means 0.25 meter per second square. Don't forget to write the unit. Don't forget to write the unit. Okay. Now for A2, what A2 will be? It will be V2 minus U2 by what? T. So here V2 is 3. U2 was 5. Now here you see, because it had applied the brakes, that is why it will be in negative acceleration. You will get negative number, okay. 3 minus 5 will be negative, of course. So T is 6. So 3 minus 5 will be minus 2 by 6. It will be minus 1 by 3. Or you can say minus 0.33 meter per second square. So this will be the final answer. These two will be the final answer. This will be the for the case 1, and this will be for case 2. It will be negative acceleration or retardation. If you are saying retardation, then never, one thing let me tell you, if you are saying retardation, then never write the value in negative. Only write 0.33 meter per second square. But if you are writing acceleration, then you will write minus 0.33 meter per second square. Okay. Retardation itself is implying that this is negative acceleration. That is why you need not to mention here minus. Okay. So 2 times minus will cancel out minus. So that is why don't mention here minus. Okay. it will be only 0.33 if you are saying retardation or deceleration, okay, or negative acceleration. So if you are using these three term, then don't use negative here. If you are writing acceleration, then you will write minus 0.33 meter per second square. Okay, fine. So this is it for this lecture. Tata, bye bye.